Welcome to this session of polynomial. In 9th standard, we have studied some basic concepts about polynomial, such as what is meant by polynomial, what is meant by its terms, degree, value of a polynomial for a particular value of variable, zeros, and how to factorize a polynomial. In 10th standard, we will study the geometrical meaning of zeros of polynomial and the relation between coefficients of a polynomial and its zeros. Before we go to the topic, we will take a brief look at what we have studied in 9th standard. In 9th standard, we have studied polynomial is a type of mathematical expression in which exponent of all variables should be whole number. Whole number means 0 along with positive integers. And if the variable of a polynomial is x, then the polynomial is represented as px or qx or gx. If the variable is y, we will represent the polynomial as py, qy, gy. And if the variable is xy, we will represent the polynomial as pxy. In 9th standard, we have studied polynomial with only one variable. Here I write some examples of polynomial. Py is equal to 2y square plus 4y plus 5. 2x is equal to s cube plus 2x plus 1 and gu. And there are some mathematical expressions which are not polynomial. That is, the exponent of the variable is not 0, it's neither 0 nor a positive integer. Then that type of mathematical expressions are not polynomials. Example, 3 root t plus t root 2. In this mathematical expression, exponent of this variable t is 1 by 2. It is a fraction, so it is not a polynomial. Consider this mathematical expression y plus 2 by y. Here, the exponent of the y, second term is y raised to minus 1. It is not a whole number, so next term. Term in a polynomial is a single mathematical expression, a variable or a constant multiplied by a variable or variables. That is constant multiplied by variables. Sometimes variable raised to a power. We have classified polynomial based on the number of terms. There are some polynomial which has only one term. Such a polynomials are called monomial. Example, 3x px is equal to 3x, px is equal to x square, pxy is equal to 4xy. So these three are three different polynomials. Polynomials with only one term. Such polynomials are called monomial. Then there are some polynomial which has only two terms, such as x plus 2, x square plus x, two terms, and 4y square plus 3xy, two terms. Such polynomials are called binomial. Polynomial with three terms are called trinomials, and polynomial with many terms are called multinomials. Terms in a polynomial separated by either plus sign or j sign. Not minus sign, plus sign or j sign. That is, when a variable is multiplied by a constant in order to form a term, then that constant is called coefficient. That is, when a term is made up of a constant multiplied by a variable or variables, then that constant is called coefficient. Then degree of polynomial. Degree of the polynomial is the highest power of the variable. The polynomial is called degree of the polynomial. Again, polynomials are classified based on the degree. If the degree is 1, something like that, x plus 1 or t plus root 2 or y, then that type of polynomials are called linear polynomials. The general form is ax plus b. Maximum number of terms should be 2, minimum 1, and that term will be ax, that is term with x. And there are polynomials with the degree 2. Such polynomials are called quadratic polynomial, and its general form is ax square, this is square, ax square plus bx plus c. Maximum number of terms should be 3, minimum 1, and that term should be, the minimum term should be term with x square. Then there are polynomial with the degree 3. That polynomials are called cubic polynomial, and its general form is ax cube plus, this is cube, ax cube plus bx square plus ex plus b. Maximum number of term is 3, minimum 1, and that term should be termed with x cubed. And these 2 points we never forget. We have also studied that a constant polynomial. The degree of a non-zero constant polynomial, this concept is very important. Non-zero constant polynomial is 0. That is, if we take the polynomial px is equal to 5, it is a non-zero constant polynomial. Next, value of a polynomial for a particular value of variable. Here we have to find the value of a polynomial at x is equal to k. Then we will represent it as pk. That is, value of the polynomial px at x is equal to k is denoted as pk. Here I write an example. Consider this polynomial px is equal to 5x minus 4x square plus 3. 3 terms are there. Degree of the polynomial is 2. We have to find the value of the polynomial at x is equal to 0. What we have to do? Replace x by 0 and do the necessary arithmetic. Then we will, that is 5 into 0. Minus 4 into 0 square plus 3. Then we will get the answer as 3. That is p0. Similarly, we can find px at x is equal to 1. Substitute x by 1 and do the necessary arithmetic. Then we will get the answer. Okay, next. 0 of a polynomial. 0 of a polynomial is the value of the variable that makes the polynomial equal to 0. Okay. That is the value of the variable that makes the polynomial equal to 0. Here I write an example. Px is equal to 3x plus 1. Check whether x is equal to minus 1 by 3, 0 of px. Substitute x by minus 1 by 3 and do the necessary arithmetic. If the answer is 0, then x is equal to minus 1 by 3 is the 0 of px. Okay. Here, while we substitute x is equal to minus 1 by 3, we will get the answer as 0. So, x is equal to minus 1 by 3 is 0 of px. As in the previous case, a non-zero constant polynomial has no 0. That is, px is equal to 5. It is a non-zero constant polynomial. It has no 0. And for a 0 polynomial, every real number is 0 polynomial. So never forget these two concepts. Every real number is 0 of a 0 polynomial and a non-zero constant polynomial has no 0. Then 0 of a linear polynomial. General form of the linear polynomial is ax plus b. How to find 0 of a linear polynomial or any other polynomial? Equate that polynomial to 0 and do the necessary arithmetic to find the value of x. Then we will get x is equal to minus b by a. Here we assume k is the 0 of px. So k is equal to minus b by a. Here b is the constant term of the polynomial and a is coefficient of x. The geometrical meaning of 0 of polynomial is the x-coordinate of the point where the graph of the polynomial intersects with the x-axis. We have already studied that every point on a Cartesian plane is represented by x-coordinate and y-coordinate, a non-ordered pair. And 0 of the polynomial is the point x-coordinate of the point where the graph intersects with the x-axis. We will look at some graph of polynomial. Then we can easily understand that concept. First we will look at the geometrical meaning of a constant polynomial. A constant polynomial is polynomial with a degree 0. A non-zero polynomial with a degree 0. Example, px is equal to 0. We have already studied that a non-zero constant polynomial has no zeros. Here the graph of the polynomial px is equal to 3. It is a horizontal line parallel to x-axis, so it will never cross the x-axis. We have already studied that 0 of a polynomial is the x-coordinate of the graph which touches the x-axis. But this line never touches the x-axis, so it has no 0. Next we will look at linear polynomial. This is the geometrical meaning of 0 of a linear polynomial. General form is ax plus b. Here We have already studied that the graph of a linear expression is a straight line. So here, if coefficient of x is positive and constant term is positive, then the slanting of the line is in this way. It will meet the x-axis at the point minus b by a 0. So this is the 0 of this polynomial. Again, sometimes the polynomial may come in this way. Ax minus b, the constant term may be negative. Then 0 will positive side of the x, that is b by a 0. This is the 0 of the polynomial. Sometimes the polynomial may be in this way, minus ax plus b. The coefficient of x may be negative. Then the line may be look like this, and it will meet the x-axis at b by a 0. That is, the line meet the positive side of the x-axis. Here, if the coefficient of x is negative and constant term is negative, then the line will meet the negative side of the x-axis, and the point is minus b by a 0. So these are all this point, and these points are all the zeros of the linear polynomial. Now we will look zeros of a quadratic polynomial. The general form of quadratic polynomial is this one: ax square plus bx plus c, and where a is not equal to 0. These are the graph of quadratic polynomial in different situations. First we will look this one. For some quadratic polynomial, the graph will cut the x-axis at two different points, and shape of this graph is called parabola. And here the opening is on upward side, and here the opening is on downward sides. This opening of parabola depends upon the value of the coefficient. Here the coefficient of x square is positive, then the opening upward. Here the coefficient of x square is negative, so opening downward. So here for two different values of x, for a particular value of x here and particular value of x here, two different values of x, this polynomial becomes 0. Thus it has two different zeros. Sometimes the polynomial, the graph of the polynomial may come in this way. Then that polynomial has only one zero. Here only one zero. Here it is also one zero. It will not cut the x-axis, it will touch the x-axis. Then it may have only one zero. Sometimes the graph may come in this way for a particular values of coefficients. Then the graph never touch the x-axis. Then we say that the polynomial has no zero. Quadratic polynomial has no zero. Here no zero. Here it may come in this way. In this case also it has no zero. So for a quadratic polynomial has maximum 2 0, 1 0, and sometimes it may not have any zero. Here is the example of some quadratic polynomial with two zeros. Px is equal to 1 minus x square, or we can write it as x square minus 1. The zeros are 1 and minus 1. These two values of x, the polynomial becomes 0. Then quadratic polynomial with only one zero, px is equal to x square. When x is equal to 0, the polynomial becomes 0. It has only one zero. And there are some polynomial with no zero. The real, I use the term real, that is when you study in higher classes you will study about complex numbers. At that time you will study about the imaginary numbers. So never get confused at this stage. With a no zero, that is Rx is equal to x square plus 1. For such a graph of this polynomial has no real zero. These are the three situations where a cubic polynomial touches the x-axis. Take the first case. Here the graph of a cubic polynomial cut the x-axis at 3 points. 1, 2, 3. So this cubic polynomial has 3 zeros. Sometimes the graph may come in this way. When the graph comes in this way, it will touch the x-axis at 2 points here and here. Then we say that this cubic polynomial has 2 zeros. Sometimes the graph may come in this way. It will touch the x-axis at only 1 point here. Then we say that a cubic polynomial has 1 zero. So for a cubic polynomial, maximum 3 zeros and minimum 1 zero. So take this first one, cubic polynomial with 3 zeros, s cube minus 4x. Such a polynomial has 3 zeros. And this is an example of cubic polynomial with 2 zeros, s cube minus x square. Px is equal to s cube minus x square. While we factorize this polynomial, we can see that this polynomial has only 2 zeros. Then px is equal to s cube. This polynomial, this cubic polynomial has only 1 zero. Do you know which is the zero of this? What's the zero of this polynomial? Yes, 0 is the zero of this cubic polynomial. So a cubic polynomial will always have at least one real zero. For a quadratic polynomial, it may not have any zero. For a cubic polynomial, will have at least one real zero. Maximum at most 3 zeros. So for a linear polynomial, it must have at least one real zero. Quadratic polynomial may have no zeros. Cubic polynomial, at least one real zero. How can we remember all these things? Yes, there is a proof for that. So, you just remember this point. A polynomial px of degree has at most n zeros. That's very easy. That is, what is the zero? A polynomial. The graph of the polynomial y is equal to px, that is, it's a form, gives in the form of a function, intersect the x-axis at most n points. That is meaning n0 means it will, the graph of this polynomial intersect the x-axis at most n points. Here the 2 points. A polynomial of even degree, that means if the degree of the polynomial is 2, 4, 6, etc., can have any number from 0 to n number of real zeros. That means maximum it have n number of real zeros. It may not have any zeros, that is 0 number of zeros. It may not have any zeros. But a polynomial of odd degree, that is 1, 3, 5, etc., have maximum n number of real zeros, but minimum 1 number of real zeros. 1. Any number from 1 to n number of real zeros. So for a even degree polynomial, maximum n number of real zeros, and it may have no zeros. For odd degree of polynomial, have maximum n number of zeros and minimum 1 number of zeros. Polynomial of degree 5 has maximum 5 number of zeros, minimum 1. Polynomial degree 6 have maximum 6 number of zeros, and it may not have any zero. Next, we will look at relationship between zeros and coefficients of a polynomial. First, we will take linear polynomial. We have studied the general form of linear polynomial. Px is equal to ax plus b, where a is not equal to 0. Here the coefficient of x is a and constant term is b. So 0 of the polynomial is minus of constant term divided by coefficient of x. How we get that? Ax plus b is equal to 0. We equate this polynomial to 0 and isolate x. Okay. So minus of b by a. That is the general form of zeros of a polynomial, linear polynomial. Next, we will take quadratic polynomial. General form of the quadratic polynomial is ax square plus bx plus c. And let me assume that let alpha, there is a Greek word here, alpha and beta are the zeros of px, that's two Greek words. Then, by splitting the middle term, that is in factorization that we have studied in 9th standards, if you have any doubt in that part, you can refer my previous video. Alpha and beta are zeros of px, then this polynomial ax square plus bx plus c can be written as k into x minus alpha into x minus beta. This expression obtained by factorization of this polynomial, by splitting the middle term. Then expand this one. This on right hand side we will get kx square minus k into alpha plus beta into x plus k alpha beta, equating coefficients of variable with the same degree, then we will get a is equal to k, x square, same degree, a is equal to k, b is equal to minus of k into alpha plus beta, c is equal to k alpha beta. Then we will get alpha plus beta is equal to alpha plus beta, that is equal to b by minus k. Here k is a, so here I will write like that. Just skip one step forward. Minus b by a. Alpha beta is equal to c by k. K is a, so that is c by a. So alpha plus beta is, alpha and beta are the zeros. So alpha plus beta is a sum of 0. Sum of 0 is equal to minus b. Minus b is coefficient of x. Minus of coefficient of x. A is coefficient of x square. And product of 0 of alpha beta is equal to constant term. C is the constant term divided by a is coefficient of x square. And in some textbooks and in not textbook, in GATE it is given that if alpha and beta are the zeros of the polynomial, then its form is x square plus alpha plus beta in the x plus alpha beta. It's not right. That is, if coefficient of x square, that is a is 1, then we can write it as polynomial as x square plus alpha beta plus x plus alpha beta. Okay, that is, here I write it as a note. If a is equal to 1, that is coefficient of x square is 1, and alpha and beta are 0 of polynomial px, then px can be written as x square plus alpha plus beta into x plus b, cubic polynomial. General form of the cubic polynomial is ax cube plus bx square plus cx plus b, and a is not equal to 0. For a cubic polynomial, number of zeros are 3, that is alpha, beta, and this word gamma. Gamma, they are Greek words, are the zeros of px. Then sum of the zeros, alpha plus beta plus gamma is equal to minus b by a, same as in the quadratic polynomials. Minus of coefficient of x square divided by coefficient of x cube. A is x cube. Product of zeros, alpha plus alpha beta gamma is equal to d by a. D is the constant term divided by coefficient of x cube. One more expression is also there, that is the sum of product of zeros taken two at a time. That means alpha beta plus beta gamma cyclic plus gamma alpha is equal to coefficient of x, that is c. Here coefficient of x divided by coefficient of x cube. How to get this expression is not required. You just remember all these things. Sum of the zeros, product of the zeros, sum of the zeros taken two at a time. In this case, if a is equal to 1, that is coefficient of s cube is equal to 1, then alpha, beta, gamma are zeros of px, then px can be written as s cube plus alpha plus beta plus gamma x square plus alpha, beta, beta, gamma, this one into x plus alpha, beta, gamma. If a not equal to 1, px is equal to k into whole bracket this one. That we will study in exercise.